Good day to you. How are you doing today? You are welcome to Star 111 class, Elementary Probability Theory. Elementary Probability Theory for ND1 students. ND1 students, Computer Science. Before everything, let's consider the course outline. This is the course outline. So it's in about 6 modules or 5 modules, so to say. The first one talks about understanding the concepts of sets and sets operations. So here we talk about sets, set operations, type of sets, and so on and so forth, and Venn diagram, and so on and so forth. Module 2 talk about the understanding mapping, function, and relation. So here we talk about the mapping, the functions, and relations, and we distinguish between functions and relations, and this relationship between functions and relations with various examples. So part 3, that's the module 3, talk about understand the concept of permutation and combination as it is used in probability. The module 4, the understanding the concept of a sample space is still part of the sample space as related to probability as well. Then the last part talk about the basic concepts of probability. Basic concept of probability. So these are the course outline, the overview of the course outline of this course. So without wasting our time, let's move to the first part of the lesson, which is the understanding the concept of sets and set operations. The concept of sets and set operations is the first one we want to consider. Now, I know a good number of us, or all of us, so to say, that we have passed through secondary school, and in SS1 to be precise, now the topic that we were taught then, talking about sets or set theory as it was called then. So now, what is a set? So there we gave us example of what set is, or the definition of what set is, example of set. Even as students in the class, we are sets. SS1 student, SS2, SS3, they are set. All the students in the school together, they are all set. Leaving that, in everyday's life, we come across phrases such as set of cutleries, set of fruits, and so on and so forth, set of numbers, set of mathematical instruments, a set of tools. It depends on the profession or the kind of, let's say for instance now, if you see nail now, you see bar, you see what's it called, hammer, and so on and so forth, then you know that these are carpenter or tools. And apart from that, let's talk about fruit now. If you see mango beside guava, orange, tangerine, and so on and so forth, you know you're talking about a set of fruits there. So sets. Now, some have a special name such as head of cattle. Yes, when you see group of cattle together, head of cattle, pack of cars, group of people, fleet of sheep or fleet of cars. So they are set when they are together. So in a nutshell, what is a set? A set can be defined as a group or collection of well-defined objects or number. It can also be called a collection of well-defined objects. That is, in those objects, something must define them. Something must bring them together. You can use a common word to describe all the words said, so that at mentioning of that particular word, there's somebody will know that, oh, this is what we are talking about. Just as the example of the fruits, whatever you see, mango, guava, tangerine, banana, plantain, and so on and so forth, then you know these are set of fruits. So in a nutshell, a set is can be defined as a collection of well-defined objects. So this object may be anything. It could be anything such as people, cars, houses, letter, countries. It's just like when you see somebody listed, like let's say Luxembourg, Malta, Italy, they're talking about set of European countries. When you come to our own continent, you see Nigeria, you see Ghana, you see Gambia, you see Sierra Leone, you see Liberia, then they're talking about set of African countries. So now this, when you see because the African countries, because they are from the same continent, that's what brings them together. But they can be mixed together. That's a set of what countries. So a set is usually denoted by capital letter. Those are the key areas that you need to know about sets. If you are representing a set, you represent a set in capital letter. not in small letter. If you use a small letter to represent a set, then that is no set. That is no set. So look at the example here. If capital E is a what is equal to, open a curly bracket, that's the even number from 1 to 20. Even number from 1 to 20. So those numbers could be listed. Even number from 1 to 20. You can see it is listed here. E is equal to 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So these are the set of even number from 1 to 20. It is very wrong for me to say to use this small e. You can see it is very wrong to use small. This is no set. So you use capital letter to represent a set. Capital letter to represent. So the element therein could be a set, could be small letter, but the bearer, the set itself, you will use capital letter to represent it. And you can see that the set is contained in the kind of a special bracket. You can see different from the normal bracket we know. This is the normal bracket we know. So if you use this bracket, normal bracket, we know that is no set. So if you contain your set in this kind of a bracket, it is no set. Let's say 1, 2, so 3. So this is no set at all. It is no set. But we use what they call curly brackets. We use curly bracket to contain a set. So curly brackets. Curly brackets. So that is this. That's it. So it's different from the normal bracket that we know. You can see. So a set is contained in curly bracket. A set is contained in curly bracket. Please take note of that. So those are the basic rules, because at times you might listed your element correctly, but if it's contained in the wrong bracket, then it is no set. Or you use a small letter to represent your set. No, it is no set. It's just like if you want to write your name. It is very wrong, it's grammatically wrong to start a proper name, proper noun, so to say, with a small letter. It is wrong. So also for set. Now, the element of a set now. What are the elements of a set? The elements of a set are the object or number that belong to that set. In a nutshell, elements of a set are the members of that set. In a nutshell, without wasting that, elements of a set are the members of that set. So the members of that set. Now, for instance, now, okay, look at these elements or the set E now. The members of the set E, they are 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. These are the members or the elements of the set. So the elements is also synonymous as the member of the set. So if you say element of the set, you are right. If you say members of the set, you are right. So just as in your own class, every student under this class is a member of that class. You are a member or the element of that class. So, for example, now all players in a particular football team are members of the team, and each student in the class, as I've mentioned before, is a member of that class, just like in this class. So, the students, the elements are usually denoted by small letter. I've said it before. While the set itself is denoted by capital letter. Please take note of this. Don't make mistake of that. So look at the example now. E.g. A, B, E, A. So they are in small letter, and the elements are separated by comma. Yes, they are separated by comma. It is very wrong to write it this way. A, B, E, A. No, this is not. This is just like just one element, like a name. So, but to what you separate the element with a comma, but how with space possible. Space. So that is how to represent the elements of a set. So the elements are separated by comma, I've mentioned, and inside a pair of curly brackets. Yes, I've mentioned it before. So this is a curly bracket. So a set is contained in curly bracket. A set is contained in curly bracket. So for example, if M is equal to this 1, 3, 5, and 7, then 3 is an element of M, since 3 is contained in set M. So that is 3 is in set M, so 3 is an element. So just as you are, each one of you is a member or the element of this class. This class, that is a star 111 class. So you are an element or a member of star 111 class. So now, let's talk about describing set now. Describing a set. How do you describe a set? It's not all the time what we write it in expression. So there are many ways to describe set. Now, The first one here is a set may be described by listing all the elements of member within a bracket. Yes, look at the example without wasting our time. Don't forget the bracket I mentioned is curly bracket. Please note curly bracket. Curly bracket. You don't just use any bracket. So you use curly bracket to contain a set. See it? So as many okay, yeah, this is it. So this is the use a curly bracket to contain a set. So loading there, so you can see it clearly now. So look at this A now, for example, A now F. That is a capital F. You see mango, you see grape, you see orange, you see guava, or you see apple. So without wasting our time, you know the F is a set of fruits. It's as simple as that. Look at M, it's a set of numbers. You can see 6, 9, 12, 15, and then so these are multiple of 3. Yes, so M is a multiple of 3. The multiples of 3 outside, excluding 3 itself. Multiples of 3 excluding 3 itself. So 6, 9, 12, 15, 18. So they are multiples of 3. So when all elements of a set are listed, it is called tabular form of a set. So this example A and B, they are called the tabular form of set. So they are called tabular form of set. That is listing them in what in the table. This is just a row. This is just a row, listing them what in a row. So note, each member is listed only once, and the order in which the members are listed is immaterial. That is, you may not arrange them in order. There is no rule that says that, and there is no penalty for that. But for simplicity's sake, so you can arrange it. But if you don't do that, it's just like as you are seated in the class. You are not sitting according to your name on the register. So you just seated anyhow. For in as much you are a member of that class and you are in the class, so that's all. So you can be referred to or can be referenced from anywhere in the class. Just as so the member of the set can be referenced from any position. So the arrangement does not really matter. So look at this example: 2, 2, 3, 3, 4, 5. So the fact that 2 and 3 were mentioned twice does not mean they were 2 in that set. It's just like as you are in the class, I mention your name twice, does not duplicate you. You are still 1 in that class. So the right way is 2, 3, 4, 5. So these are the members. So this one we have and we have just 4 members. That is 2, 3, 4, 5. But 2 and 3 were mentioned twice or listed twice. So that does not duplicate them. It's just 1. So now these are those that they are the same because the set does not contain repeated number. So set does not recognize repeated number. You can list a member or an element twice or thrice. That does not make it to be more than that. So it is referred to as just 1, just as you are. So you are 1 and you are unique. So it can't be duplicated. It's not possible. So just likewise in set. So now a set may be described in words. Yeah, you can use the word to describe the set. For example, now M is a multiple of 3 from 3 to 18, just as we have it here. So M is a multiple of 3 from 3 to 18. Now, how do we list that M? Just say M is equal to, yes, open a curly bracket, yes. So say from multiples of 3 from 3 to 18. So from 3 to 18, that would be 3, 6, what again? 9, 12, comma 15 and 18. So this is what this set is talking about. That is the multiple of 3 from 3 to 18. So from 3 to 18. So this is the what this set. So describing it what. So now in a question they can just give us like this: M is what is equal to multiple of 3 from 3 to 18. So it is now left for us what to list the element as I did here. So to list it this way, it's now left for us so like this. Unlike this, the first one that has been listed, so they can describe it what in words. So they are meant what to list that. Now the second one says C is what constant. No, consonant. Sorry, C is equal to consonant. What are the consonants? That is the alphabet minus vowel, which is A, E, I, O, U. So the rest are consonant. Then D is a domestic animal. So in that set, any domestic animal will be listed. Be it dog, cat, hen, or fowls or dog and so on and so forth. So these are domestic animals. So D is a domestic animal. So then note something that capital letters are used to denote those sets. So it's very important what you take note of that. So that's two. Talk about set may be defined, described by listing all the elements, may be described by what in words, and the number three may be described algebraically. May be described algebraically. Now, for instance, so they said, okay, for example, now B is a sort of a set X, is a set of X, such that X is greater than 10, less than or equal to 3. X is greater than 10, less than or equal to 3. I know you know an X is an integer yet that we define. Now, for you to list these elements now, there are some things that you need to understand. Number one, what is an integer? You need to understand what an integer is, and how to read this inequality. This is going to say for what you should see is minus 10 less than x less than equal to 3. That's what you see. Yes, but it is not read that way. You start from x. No, if minus 10 is less than x, then x is greater than minus 10. So maybe let me open a notepad for us to see so that you can understand it better. Let me open a notepad. Yes, this is a notepad. This is a notepad. Now, this is this is the inequality we are talking about. Let me just copy it that so that you can understand it better. Let me type it. Something is there. X is such that minus 10 is less than x less than equal to 13. Such that minus 10 is less than now. So let's look at this minus 10 is less than x. If I say minus 10 is less than this same thing is equal to the same thing as the same as x is greater than minus 10. So this minus 10 is less than x, same thing as x greater than minus 10. For example, now if I say I am older than you and you are younger to me, we are saying the same thing in different ways. So if you want to read this now, you say x is such that x is greater than minus 10, less than or equal to 13. Let's back to a page now. Now, this means B is the set of number x such that x is a whole number greater than minus 10 but less than or equal to 3. Less than. So a set specified in this way is known as a set builder notation. So this is what they call set builder notation. So when you describe set algebraically, you use algebraic expression to describe your set. Now, in listing the element of this set now, don't forget they said x is an integer. Then what's an integer? You have to understand what an integer is. An integer is a positive or negative whole number. an integer is a positive or negative whole number. So you need to understand that. So having understand that, now you can go ahead and list the element of this set. Let me just do it here. The element of this set. Now set x is what? Greater than minus 10, less than equal to 2. What are numbers greater than minus 10? These are minus 9. You don't know minus 9 greater than minus 10. So minus 9, minus 8, minus 7, minus 6, minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3. So then you close the curly bracket. So this is the set now. You can say m now, m is equal to this. So this is what we describe it as x is greater than minus 10, less than equal to 3 is this. Look at the word equal to, because 3 is there because it says equal to. If you say less than 3, then 3 will not be there. So this is what is set m now. These are the elements in set m now. So that is that. Now let's move on to the types of set now. Types of set. Now types of set now, we have the finite set. That's first one, finite set. What's the finite set? It's a set in which all its members or elements can be listed. All the elements or the members can be listed. Look at this set M now. Is it a finite or infinite set? Of course, it's a finite set because we can list all the members of the set. We can list all the members of the set. So it is a finite set. So now, if M is a set of the months in a year, then M is a finite set. Yes, of course, because we know all the months of in a year, they are just 12. They can be listed. We can list them one after the other from January to December. So these are these one are finite. Then other one is infinite set. Infinite set. An infinite set is a set in which all its members cannot be listed. We don't know them all. For example, now if B is an odd number greater than 5, then B is an infinite set because we only know number greater than 5, odd number greater than 5 start from 7, 9. In that order, and in as much you don't know the known number, counting number, then we will not know how many elements are in that set. So such a set is an infinite set. You just to say a set of even number. Set of even number, they are infinite. They start from beginning to what? They start from infinity to infinity. We only know that 0 is the origin of number. To the left is negative, to the right is positive. I don't know how many are there. So such sets are infinite sets. So notice that the first few numbers are listed to show the pattern, and the then dotted dots are used to show that the pattern continues indefinitely. You can see that's why I see 3 dots after 15 dot. So it shows that once you are asked to list the element of an infinite set, list the few one to show the pattern, then use dot to come. So if you stop at the last one, then you have defined it to be infinite, which makes you wrong. Now another one is an empty set or non-set. And an empty set is a set that has no elements. The empty set is a set without any element or member. It is called a non-set or an empty set. So it can be called a non-set or it can be called an empty set. So empty sets, the empty set is usually represented by the symbol, that is, you open a curly bracket, then close it together, that's an empty, then give a space and close it, nothing there. Then or use what a phi, that's one of the Greek symbol, phi. So this is it. So phi as what? As to represent an empty set. So you can use a phi, or you want to open a curly bracket and close it, so without anything. Mind you, if you put a dot, inside that, in between the bracket, then it shows that element that set is not a non-set again. That dot serves as an element of that set. So if M is a month with 2 letters, then M is an empty set. A month, there is no month with 2 letters. The least you can have is 3 letters, which is May. which is May, and so there is no month of the year that start with. So such a set is an set. So this is what you are going to do. M is this, that's open and close a curly bracket, or use the 5 to represent. So because no month with only 2 letters, so know that number 0 is different from an empty set. I said it. 0 is an element. Don't say because it has nothing there, you just use 0 to represent. No, 0 is an element on its own. So 0 is what is a number, and it can be counted as just one element. So that is that. Now look at this exercise. So you can lay your hand on it. State which of the following set is which of the following state which of the following is a set. Yes, this is a set. In line with what I've taught you so far, which of them is a set? Is it A, B, or C? You can see A are listed. Add anything there, B and that. So C is this and D. So that left to you. Then list the elements of each of the following sets. So odd number between 10 to 30. How many elements do we have there? So you first list it before you can count the number of elements there. Prime number between 10 to 40. Factor of 24. Write down the next 4 elements of each of the following sets. So you know this is like an infinite set, but you have to write the next 4 elements following the pattern. So that's that. Now let's move on to the next one now, which is a Venn diagram. Venn diagram. So a Venn diagram, a set can be represented by showing its elements within a boundary, usually a circle or a ring. A circle or a ring. I know, as I mentioned, Venn diagram, we recollect in those days when we did set in SS class. SS1 to be precise, Venn diagram. So where we drawing circles and intersecting each other, all this and that. So still that same Venn diagram I'm talking about. So representing a set in a boundary, either a circle or a ring, as shown in the diagram below. So a diagram such as this is that helps to show the relationship between sets is called a Venn diagram, named after a French mathematician, that's Venn, who first represented sets diagrammatically in 19th century. So he was the one that first did that, and that was why it was named after him. It's a Venn. So that's what called Venn diagram. So now look at this example now. F now, that's a represent family. Once you see F, you see father, mother, and son. Father, mother, son. So that is family. So F is family. Then it can be what in a this is a circle. This is a circle, and this is what the oval or ring. So father, mother, and sons, or this. So this is a set now. It can be represented what this way. So this is what they call Venn diagram. So example now, look at this number. Venn diagram. If you draw a Venn diagram to show A is equal to 13579. Solution, you can see A. Don't forget capital letter to represent the set. Then draw your oval or your circle. Then list the element there. Anyhow, I told you the arrangement does not matter. It may not. There's no rule that say they must follow a definite arrangement. The pattern is different from arrangement. No, the pattern describes the set. But the arrangement in the curly bracket or whatever you want to contain them does not really matter. So now that is that. Another thing is a subset. Let's talk about subset now. A set A is a subset of B if and only every member of A is a member of B. Yes, subset. Let me just give an example. You are a set of computer science students. So you are a subset of students in your school, or in your faculty, or in the entire school at large. You are a subset because you are a set within the set of students in that particular school. So we can say set A is a subset of B if and only if every member of A is a member of, that is, every member you can see in set A, they are in set B. Every one of you are a student of your institution. So you are a subset of what? To that set of students in that school. So consider the sets now. Look at this. We have 2, 4, 6, 8, 10, 12, 14, 16. And we also have set B as 2, 6, 10, 12, 14. Now, if you look at it, you can see every element of B. Every element of B can be found in S. every element of B, that is 2, 6, 10, 12, 14, they are found in S. So we can say that B is a subset of S. B is a subset of S. B is a subset of S. So B is a subset of S. B is a subset of S. So yes. So we use this symbol, or we say, okay, B is a subset of S, or we say B is contained in S. B is contained in S. So the symbol, so this is what we used to say was the symbol, this particular symbol. Yes. Sorry. So this symbol is used to say also to denote that one is contained in what in the other. So this symbol is not a C, it resembles C, but it's not C, it's a symbol. It's used to represent this that set, one set is subset of another. So when you see this, that is C, the one that normally represents C, that follow the pattern of C, but not C as it is well. So it's used to, it's a symbol that represents that shows that the set is a subset of another. So if we say that what, so B is a subset of of S, so to say. So then thus B is read as a, so B is a subset of S, or B is contained in S. So this statement that is S means that what S is what superset of B. So S is superset of B. So or S contain B. So S contain B. So thus a set that contains another set is called superset. So in Venn diagram, the Venn diagram of set S, so set B of 0 and B is contained is a subset. Sorry, okay. They are shown what below this. So set B and B, the subset are shown in the what below. So look at this now. Look at set S now. Look at set S. We have the elements, so you can expand it very well. Yeah. So this set S now, we have 2, 4, 6, 8, 10, 12, 14, 16. Just as we have it here now, we have set B now. Let's set B, yes. Set B. B 2, 6, 10, 12, 14. So this is set A, set S, this is set B. So we can have set B inside set what? Set A. Look at the ring for set B now. What are the elements we have there? We have 2. So then we have 2, 6, 10, 12, and 14 in what? In B, and the other one is set S containing the remaining one, which are discovered, which are 4, 16, and the other one. So the 4, 14, and 16 here. So we can say that B is a subset of S. B, so because S contains B, that means you can say S swallow B completely. You can see every element, everything that we call B is what is inside S, and it does not affect everything that's in there. So every element in S, you can still find its work in this ring. Likewise, those that are in B are there. So let's look at this example now. If A is this 2, 4, 6, 8, and 10, and B is there 2, 2, 6, 8. So we have to do a Venn diagram to show that the element of set A and set B, and this is solution. You can see the smaller ring. What element do we have there? 2, 6, 8. Then you can see the bigger one. So now what is left now? We have in A we have 2, 4, 6, 8, 10. Then in B we have 2, 6, 8. So 2, 6, 8 is in B. Then the remaining one is what? 4 and what? And 10. So we now look at A as a whole. You see your 2, 4, 6, 8, and 10 here. So B is a subset of A. B is a subset of A. Say A is a superset of B. A is a superset of. So let's talk about power sets and the number of subsets now. power set and the number of subsets. So the power set of a set is a list of all of its possible subsets. The set of all its possible subsets. Underline possible subset. It's not the set is summarized as a subset, and set within a set. Now, if A is what is this now? 1, 2, 3 to infinity now. So the power set of A is what is the 2 raised power what? A. 2 raised power A. It's the 2 raised power A should be 2 raised power n, where n is the number of 2 raised power A. Thus, if A is what 1, 3, the power set of A is a 2 raised power that A, so which is a 4. So let's say it's 2 raised power n, sorry, 2 raised power n, where n is the number of elements in that set. So that's number of subsets. So number of subsets in elements is 2 raised power n, where n is the number of elements in that set. Now look at this now. This is a that's 2 elements. This is a 2 raised power 2 is 4. So that's how we have it. Now, how do we now get those subsets? Let me just use this one as an example. We have 1 can stand, it's a singleton set, it's a set. 3 can stand, 1 and 3 is also a set. Then you cannot say, how do we now get the last one? The last one is what is the empty set. So there is a rule in set that says that every set is a subset of a set, and empty set is a subset of all sets. Get it clear? Every set is a subset of a set. Empty set is a subset of all sets. If you look at the subset now, you can see that 1 and 3, which is the set itself is here, then empty set. So that's how we are asked for. So when we are listing subset of any set now, after clearing the elements one by one, and so you see that it's now left to you to find maybe the remaining two. The remaining two will now be the set itself and the empty set. So that's how to list the subset of all of sets. Now, if a set contains n member, then number of possible subsets that can be obtained is given as n is equal to 2 raised power n, where n denotes the number of elements in the set. So thus, if A is this, then n is equal to 2. So the number of possible subsets is 2 raised power n is equal to 4. So a set contains 7 members. Find the number of subsets that can be obtained from it. That is 2 raised power 7, which is 120. Very simple. 2 raised power 7, which is 110. No, it's not 2 times 7. 2 times 7 is 14. This is 2 raised power 7. That's 2 times 2 times 22 in 7 places. So then let's talk about the universal set. Let's talk about universal set. Sorry. Let me see. We can finish this one, this module. I don't want to go beyond the 1 hour. So yes, universal sets. So universal sets for any given problem is a set that contains all the members which can be used for that problem. So the universal set is usually represented by the symbol E. It's not E as it is, but or U. E or U. Or it's not U, but let's take it as U. So E or U. That's the way it is written in form of what? Of a symbol, not as letter E. And likewise not like letter U. But let's take this one as a universal set. So this or this as a universal set. So for example now, if we have our E is 1, 2, 3, 4, 5, 7, 8, 9, and A is this now. So A is a subset of E. That is, every element of A can be found in E. So we can say A is a subset of E, or E is a superset of A. A is a subset of E, or E is a superset of A, as I mentioned earlier. Now, similarly, if B is a 1, 3, 5, 7, these are the set of elements in B, then B is also a subset of E, or E is a superset of B, because we can find the element, both the elements in A and B, we can find them in E. They are all in E. So E is a superset to both set A and B, or we can say both set A and B, they are the subsets of set E. So in Venn diagram, the universal set is usually represented by a rectangle, and any subset is represented by a circle enclosed within the rectangle. So the diagram, So below, show that A okay, so the symbol means it's not. So this symbol, yes, this one, yeah, this symbol shows that. Let me bring this here. Bring this here. So this one shows that what that A is the subset of what E, and this one shows that what is not the subset of what of E. So diagram to this shows that A is the subset of E. Then the symbol, you see this symbol now, what shows that what is not the subset. So when you are got something like the subset and you buy it across it, so the subset means that okay, it's not a subset of the universal set. So now let's look at it now. What is set? That set A now we have 2, 3, 5, 6, 7, 2, 3, 5, 6, 7, and that's A now. Then the other one that is universal set, they are what 1, 4, 8, and 9. So everything, when we look at E together, you can find all the elements. That's 1, 2, 3, 4, 5, 6, 7, 8, and 9. So that is how to that is the universal set. So it contains all the, even if you want to look at B, yes, B now we have what 1, 3, 5, 7, 10. Yeah, so you can still look at it, and then we look at A and B, they have 3 and 3, 5, 7 as their what as their common element. So you can draw another circle. So we have that at the point of intersection we have 3, 5, and 7 here, then all elements will go where it's supposed to be. So, for example, now you said C is a minus 5, minus 4, this and this, then C is not a subset of the universal set. Yes. C is not a subset of the universal set. So, C is not a subset of the universal set. That is. So, like this, C is not a subset of the universal set. So now, set video notation, I've mentioned it before. I said it when we are talking about describing sets, how to describe sets. So a set specified by using algebraic expression such as this x, this colon represents such that, or this forward slash is a, in mathematics they stand as such as. So x is less than or equal to 8. That's a, or sorry, okay, x is less than or equal to 8. So it's called a set video notation, where the colon or the stroke means such that. I mentioned it thus. They are both set reads. A is a set of value of x such that x is less than or equal to 8. Note that this is possible to list the elements of the set given in the set video notation. In set video notation, in this case, we have this now. So it's such a case that what x is greater than or no less than or equal to 8. So is an infinite set because we don't know the beginning. Only on they did not tell us that the length is as an integer or this or that. So only that what is x is less than or equal to. So any number less than or equal to it, they are in that set. So we can see from the beginning, the negative side we don't know. We only started from -3, -2, and all you know that what the last number there is 8. Look at this. If b now, if x is such that x squared minus 4 is equal to 5, then a is a set of number such that x is this. So this is a quadratic equation. So we need to solve quadratic equation before we can get the elements in set. After solving it, the elements in set a or whatever the set is what is -1, 5. These are the elements. So consider another algebraic expression like this. In this case, remember b are only what integers. No, sorry, x is such that x is less than, so x is greater than 5, less than or equal to 10. X is greater than 5, less than or equal to 10, and x is an integer. I'll define an integer for us. An integer is a positive or negative whole number. Positive or negative whole number is an integer. So in this case now, b is a set of numbers such that this x is greater than 5 but less than or equal to 10. So what's number greater than 5 as an integer is 6. Then this 6, 7, 8, 9, 10 is the elements in that particular set. So if you look at this, n is a natural number, w is whole number, q is a rational number, and r is real number. So this should have been done in your MTH 113 or 111, as the case may be. So look at this, show that A is what? It's a set of x such that x is greater than minus 4 less than or equal to 5 is a subset of B, which is a set of x such that x is greater than or equal to 7 less than or equal to 6. Now solution, now you have to list all the elements in A, that is x is greater than minus 4 less than or equal to 5. So these are the elements. Then B is greater than minus 7 less than or equal to 6. These are the elements in B. Since all the elements of A are in B, so A is a subset of B. Yes, you can see all these elements in A, they are also in B. So we can say A is a subset of B. A is a subset of B. So the number of elements in a set now. Number of elements in a set is what we refer to as the cardinality of a set. It can be called the cardinality of a set. Cardinality of a set. So cardinality of a set. So look at this set P now. We have 2, 3, 5, 7, 11, and M is a Dassault, Toyota, Mazda, Nissan. So this one has how many? 4 elements. This one has 5 elements. So there are 5 elements in P and there are 4 elements in M. So n of P is equal to 5 and n of M is equal to 4. That is number of elements in P is 5. So number of elements in M is 4. So if it, somewhere they can say the cardinality. So cardinality or number of elements is equal to the same thing. So where n of P means and n of M means the number of elements in P and M. So note that a set that contains only one element, yes, it's called singleton set. No, we have talked about empty set, the one that has no elements, but any set that has one element is called singleton set. So let's talk about equivalent set now. Equivalent set now. You know, there's a between equality of set and equivalent set. So two sets are equivalent if they have equal number of elements. Get it clear? Equal number of elements. It does not really mean that the element must be exactly the same, but so for equivalent set now, you talk about the cardinality of that set. So look at set P now. It has the ABC. Set Q has mango, guava, and apple. So both of them are equivalent because they have 3 elements each. So the same number of elements. So the same number of elements each. So now look at this example. Say whether the sets are equivalent or not. V is such X is a vowel. N is this 1, 2, 3, 4, 5. So then B is this and this. So the two sets, they are equivalent because vowel is 5, then number of elements in N is also 5. So NP is equivalent to N. You can see that the symbol used like a 3 equal to which one? No, 3 bars. 1, 2, 3 equal bars. So that is equivalent, different from equal to. So different from equal to. So but it's equivalent to B is equivalent to N. So look at B now. This is an empty set. It has no element. This is also an empty set. So the two sets. Okay. The empty set. So this contains empty set. Oh, sorry. B is not equivalent because the first one is an empty set. The second one has empty set as its own set, so they are not equivalent. So this one, this is a singleton set. Sorry, so this is a singleton set. So this is not the empty set is not equivalent to this one because this one has one element. I told you. The fact that it's a set within a set, so it has an element. So that empty set is an element. Then equality of the set now. Two sets are said to be equal if they have exactly the same member. So this is different from equivalent. Equivalent talk about the cardinality, but equality talk about the same member. Exact. So the member must be exactly the same thing. So this means every member which belong to the first set belong to the second set and vice versa. So for example, now look at 1, 4, 9, 16 and Q 4, 1, 16, 9. So P is equal to Q. I've told you arrangement does not matter. It doesn't matter in set. So just make sure you are the element is there where it's supposed to be. So the position does not really matter. So although elements of P and Q are not arranged the same way, they are still equal. Therefore, the order or the arrangement in which the members are written does not change the set. They have used the example severally. In your class, your manner of the arrangement does not matter, in as much as in that class you are there. So where you are seated does not really matter. So now, example, now determine whether the pair of the sets are equal or not. Look at this. Are they equal or not? So now m is the factor of 12, then m is equal to 1, 2, 3, 6, 12, and the n is this. So they are equal. Both sets have the same number of what? The same element. Because although n was not arranged properly, but it still contains the same element as m. So m is equal to n. So they are equal. Look at it. There are difference between equality and equivalent set. Equivalent set must have, talk about cardinality, a number of elements. So while equality set must have the same thing. So they must look alike. So what you find in A, you must also find it what in B for them to be equal. Know that all equal sets are equivalent, but not all equivalent sets are necessarily not necessarily equal. Yes. All equal sets are equivalent, yes, because they have the same number of elements, they obey the law, but not all equivalent sets are necessarily equal. Look at the example above. So they are not equal because look at this mango, guava, apple, and ABC. They are not the same. Cardinality may be the same, but they do not look alike. So, and that is that. And okay, before we go, let's talk about the union and intersection of the sets now. So these are the exercises, you can lay your hand on it. Then the union and intersection of the sets. The union of the sets A and B is the set of all members that belong to A or B. Let me pick the word union from the word marriage. Let me use that. The union of coming together of family A and family B and become one. So that is in union set. Now, elements in A, elements in B coming together, mixed together. That is the union. So this may be written as A U B. That's A union B, where the U means union. It means union. You can see this U is quite different from universal. So this is A union B. Read A union B. A union B may also express in the set builder notation that is like this. That is X, so that X containing A or X containing what in B. That is the elements in that universal, the union, they have the A what containing both A and B. Let me use you as an example. You are product of two families, so you belong to the two families. Two families can lay claim on you. They can see and say, oh, this is our child, this is our child. Go to your father's side and your mother's side. So if A, B, C, D, if A is equal to A, B, C, and B is a B, D, E, F, so then A union B, you list all the elements. You can see it's combination of A, B, C, D, E, F. A, B, C, D, E, F. That's it. The intersection now, quickly. Let's talk about the intersection now. Intersection of the set. Intersection of the set A and B is the set of members that are common to both A and B. That are common to both A and B. That are common to both A and B. So, the other time I used you as a union. Yes, okay, the coming together of the two families is union, but you are the intersection here between the two families. The child is the intersection, is the what connects the two families together. So the child is what connects the two families together because it belongs to both family A and what and B, the intersection. So if two families they're involved in marriage and there is no child, they will have common intersection, but once the child is there, then that is the intersection. Let me use that word for us to understand. So intersection of A and B is usually written A and B, where this N, this symbol means intersection. You may also express it in this way, that is this. So A, okay, that's this should not be A, this should be or it should not be all, and X is containing what? So that X is containing A and X is containing B. So this is union, this is and so for example, now if student taking further math, that's F, student taking biology, then F intersection B, student taking both subjects, yes, both subjects. So this joint set, or let me use maybe a set of computer science students and we have a set of statistics students and you're all taking math 113, MT 113. So that course is the intersection between you. At that point, at MT 113, all of you will come together. That is the intersection of everything. So now, two sets A and B are set to disjoin if they have no common element, common member, and the common element, yes, that is, if there is no connection, no member of A is in B and B is in A and vice versa. So in that case, A in the disjoint set, A intersection B is always an empty set. Look at the example now. A is an odd number, M is what? The multiple of 4. Look at A, odd number, that's the 1, 3, 5, all this and that, 1, 3, 5, 7, and M is the multiple of 4. Look at them. There is no intersection between odd number and multiple of what? 4. There is no. So notice that multiple of 4 are even number, since set O and M cannot have common elements. So the O intersection M is an empty set. Then complement of the set now. The number of elements in the universal set that are not in set A are called the complement of the set, and denoted by A prime or A raised power C, A prime or A raised power C. So A complement, that is. Let me just use your class as an example. You are a set of computer science students. If another student from, let's say, BizAdmin come into the class now, such a student or such a member is a complement to your set. He or she is a member of student of the school, is part of the universal set, but is not a member of that particular class. And you want to, so such a student is a complement to that set. Let me use another example. Maybe in your own family now, you have somebody that's not a member of your family and come to be with you or greet you. So that person is a complement to your family, so a member of your family. So that is that. And in as much that person is a member of your universal or your compound family for extended family. So that person is a complement to your family. So that is that. And today now we talk about the sets, definition of the sets, and from there we could go to the types of sets, describing a set, the types of set, talk about the Venn diagram, and from there we talk about power and the number of subsets in the set, talk about the universal set, set-design notation, talk about the equivalent set, the equal set, we talk about the intersection and the union of the set. So these are what we discussed, and please, all the exercises therein, please, I want you to do it religiously. Please see yourself, make sure you go through them. So that is that. So next time we need to talk about understand the mapping and function. Mapping and function is the next one. So thank you for listening.